so when solving absolute value inequalities, you're always going to have two cases. You know how on the board over there we split it into, like when it said the absolute value of x equals 3? What are the two things that x could be?
3 and negative.
It could be 3 or it could be negative 3. So you're always going to have two options. You're always going to have the situation where what's inside the absolute value bars could be positive, and then what's inside the absolute value bars could be negative. So that's what that says right here. If the inequality contains less than or less than or equal to, the solution is an intersection. So what kind of problems do we graph the intersection?
And.
Okay, and then if the inequality contains greater than or equal to, the solution is the union of the two solutions. So those are going to be OR problems. This is probably the most important part of the whole notes. I would highlight this. So example 1, if the absolute value of 3p minus 12 is less than 9. So the first thing you want to decide is this going to be an AND or an OR problem? It's less than, so less than is AND. So you're going to write your two cases. So case 1 is whatever is inside the absolute value bars is positive. So to get case 1, it's going to be this exact same inequality, just drop the absolute value bars. Okay, so to get case 2, it's going to be the same, what is inside the absolute value bars, so the 3p minus 12. But on this one, you're going to swap the sign. So instead of having a less than sign, we're going to have greater than. And instead of having 9, we're going to have negative 9. Okay, if you look over here on the board that we just talked about, it's the same thing. Okay, we had less than or equal to 3, and then we changed it to greater than or equal to negative 3. It's the exact same thing. Okay, every single time you're going to change the inequality sign, and then you're going to change that last number to a negative. So I'm going to write that down right here. Change the inequality and make 9 negative. Now on your own, go ahead and solve both of these. So you should get P is less than 7 and then P is greater than 1. So just keep in mind, is this an and or an or problem? And. Okay, so because it's an and, that means when we graph it, we're looking for the intersection. So you don't have to do this, but I'm going to sketch a little graph to the side to see what is this going to look like before I draw it on the final graph. So I have 1 and 7. I know it's going to be an open circle at 1, and then I'm going to shade to the right. And I know it's going to be an open circle at 7, and I'm going to shade to the left. So my answer is where these two lines intersect, or where they overlap. So for these, it's always going to be in between the two numbers for the and. You're going to see this video at the end of class, and it says the answer is going to be nested between the two numbers. That means it's going to be all the space in between the two numbers. So you probably, on these, don't even have to sketch the graph just before you do your final graph, because if it's and, it'll always be in between. One thing I do want us to get more comfortable with is writing these answers in set builder notation. So if you don't know how to do that, pay close attention to how I'm doing this. Hey, remember, you're always going to use less than or equal to when doing this. So start on the left side. My first number is going to be 1. Do I say less than or equal? Less than, P. And then my next number is 7, but do I say less than or equal? Open, so just less than 7. And that's my answer. 1 is less than P and less than 7. Okay, any questions on the first one? I want you to highlight this second example and go ahead and read it on your own. Then I want to see if somebody can tell me what this is saying. This is a very, very important example. Okay, why is the answer to this no solution? Okay, I'll think it through. Why would the answer to this be no solution? Why does it not work? Devin?
Because if it's the equation is the absolute value, it is always going to be positive, unless it's a negative sign.
Exactly right. Okay, so is it possible to take the absolute value of something and it be less than negative 10? It's not possible. Okay, so this is what you're looking for right here. If it ever says less than a negative number, then your answer is going to be no solution. You don't have to do any work at all, because absolute value is the distance a number is away from 0. Well, distance can't be negative, so it's impossible for a distance to be less than negative 10. We say no solution. That's something a lot of people miss, because this is going to work. Like, I could work this out just like the one above it and get my case 1 and case 2 and do all that stuff, and my answer might look like it's right. Like, all my work might be correct, but I have to catch that at the beginning of the problem. So on your homework, I may just look through all the problems and look for something like this. Look for less than a negative. And if you see that, go ahead and write no solution. Okay, go to the next page. So this is an example of a greater than. Okay, so if it is a greater than problem, is it and or? On the video that I'm going to show you, it's going to say or is more. Okay, that's the way you can remember. Or is greater than, or is more. Okay, so we're going to do case 1 and case 2 just like the last one. Case 1 is going to be exactly what we're starting with. Just drop the absolute value bars. So x minus 7 is greater than 4. Case 2 is going to be x minus 7. I need to switch the sign. So it's going to be less than. And I need to change the 4 to negative 4. Okay, go ahead and solve both of those. Okay, so you should get x is greater than 11 or x is less than 3. So this is an or problem. So what is my graph? Is it the intersection?
No.
It's everything. Okay, so on these I normally don't sketch it first. They're always going to be going in opposite directions for the or. Okay, so I can say open circle at 11 and shade to the right, and then open circle at 3, shade to the left. Don't forget to write your answer in step builder notation. So I say for all x, x is less than 3, or x is greater than 11. No, that's a good question. It doesn't matter what order you put these two in. On the and, you do need to go left to right, like least to greatest. But on the or, it doesn't really matter. And I try to go least to greatest, but it doesn't matter. Okay, so this example right here, this is the other kind of special situation. I want you to highlight this one as well. And go ahead and read it on your own. Try to tell me what is this saying? Okay, so who can tell me what this does? Why is the answer all real numbers? Why does that happen? Rory? Okay, well, this actually doesn't even matter. It doesn't matter what this is. The only thing that matters is right here. Okay, so can an absolute value ever be negative? No. So no matter what x is, when I take the absolute value of it, I'm going to get a positive number. So any positive number is greater than or equal to negative 4. It's greater than a negative number. So this is what you're looking for right here. A greater than or equal to a negative number. That will make it no solution. I'm sorry, that'll make it all real numbers. So what do you write if you have less than or equal to a negative? If you have less than, no solution. Okay, that's what's on the previous page. If it's greater than any real number. Okay, do y'all know how to do the number line for this? The whole thing, yeah. This was actually on your quiz yesterday. I'm not going to take off if you didn't know how to do the number line for this, because we haven't really talked about it. But you do actually just shade the whole thing. Because it can be anything. Yes.
So like if you left the number line blank, you didn't know how to do it.
I'm not going to take off. Yeah. Like, I will take off if you didn't write any real number as your answer, but if you left the number on blank, then it's fine. Just from now on, we'll know. Okay, in the last example, does anybody remember there's a special formula we had for writing equations with absolute value? Anybody remember what that is? It's been a long time. This is the start of it. I think if I tell you how to start it, then you'll remember. What's the next part? Y'all know it. Is it in your brain? I'm thinking of a different formula. Okay. Almost. Distance from midpoint. So on this, you're going to have some sign right here. It's going to be either less than or equal to, or greater than. It's going to depend on the problem. So that's why I'm writing that. And then on this side, it'll be distance from the midpoint. So what you're going to realize in especially a lot of the higher math classes, absolute value isn't always just talking about the distance from 0. It's talking about the distance from any number. So in this midpoint, this is what we're the distance from. If you read this problem, it says the average depth of a river is 4 feet. With the rainfall and evaporation, the depth of the river is within 0.25 of the average depth. So that's saying we want, like normally the river is 4 feet deep, but it can vary 0.25 of that. So in this case, the midpoint is going to be 4. And it says the depth of the river is within 0.25 feet of the average depth. So it's going to be less than or equal to 0.25. So now I want to solve this to figure out what it could be. Case 1 is going to be x minus 4 is less than or equal to 0.25. Who knows what case 2 is going to be? Carson, you know? Yeah. Okay, so now we can solve both of these to get our answer. So this is an and problem. I know that because I wrote less than right here. It's got to be between these two values. So that means I can write it together like this. Okay, it's going to be the smaller number, x, the bigger number. Okay, it's between these two numbers. Okay, so if you've forgotten that formula, make sure you rememorize it, because you will need it.